Hi. Today I'm going to show how you can create a hash table and look up an element in that hash table. So what is a hash table? You can think of it as a data structure that you can use to organize elements such as integers and look up those elements faster. In order to organize the elements, you use a hash function. So I have here an example. The hash function in this example is h of x is equal to x mod 10. So this means that for each element x, x mod 10 gives you the remainder of dividing x by 10. And this gives you the number of the bucket where you can put the original element. So for example, 120 divided by 10 is 12 and gives the remainder 0. So we will put it in the 0 bucket. Some buckets will be empty. Then 13 divided by 10 gives a remainder 3, so we put it in the bucket 3. Some buckets, such as this one, will have multiple elements because both 34 and 4 give the remainder 4. And similarly, 5 and 15 will both go in the bucket 5. So how does that help us? Well, if you are given a list of integers, you first distribute them in the buckets, in the hash table. And when you get a new element that you want to see if that element is in the hash table or not, what do? First, you have to get the remainder of that element when it is divided by 10. So let's say that the element is 99. 99 mod 10 is equal to 9. So if that element was in the initial list of elements, then it would be in the bucket 9. So I look in the bucket 9, there is nothing here. So it means that the original element, 99, is not in our given list of elements. Now I'm going to look at the C++ code that creates a hash table and looks up an element in that hash table. Here I include the IOStream library and the vector library. The IOStream library in C++ contains functions that allow you to write out strings to the console or read input integers or strings, whatever, from the user. Vector is a library that contains functions related to vectors, of course. Now I have a structure here called node. A structure is like similar to a class in C++ in that it has fields such as value and next and functions. This is a constructor here. So the fields are value of type integer and next of type a pointer to node. So this one says that each element of type node will have an integer and will also have this pointer to the next value, which will be also of type node. So this essentially gives you a linked list. And I have here visual representation of the linked list. So you can, when you think of a linked list in C++, but in any language, you first have the actual value, which is an integer in our case. And then here, this part is a pointer to the next element of type node. And similarly, this goes to the next element of type node until there is no more next element. And in that case, we have a null value representing the null pointer. So there is nothing there. And here, this is creating the node element. You give you have two values of type integer and a pointer to the node, and that you're giving as input, and value, which is the same one as the field here, will take this syntax here means that the field value will be equal to value underscore at the end of this constructor. And then here, the next field will be equal to next underscore that you gave in as input to this constructor. A constructor is, you can think of it as a function that creates a new object, because C++ is an object-oriented language. Now I wrote here a function insert at beginning, which takes in an integer val that I want to insert at the beginning of this list. So it will be around here. And old head, which means I want to put a new element in front of old head. So in our example here, old head will be this element with a value 5. On this line here, I create a new structure, a pointer to node called new head, and I give it the value val underscore and null, since now I don't know what this new node is going to point to. The next field of new head will be equal to old head. So now I connect the new head with the existing structure that starts at old head. And since we are talking about pointers, now old head will be equal to new head. Old head represents exactly the pointer to the beginning of the list. Now I have a function add to hash table, which takes in the hash table, which I represented as a vector of linked lists. This part here, the ampersand, means that it is a reference. So by a reference, I mean that whatever happens in this function to hash table will be permanent. So once you exit the function, the changes will still be there in hash table. And then I have the value val that I want to put into the hash table. First, I want to see which is the bucket where I should put val. So I do val mod 10 is equal modulo 10. So it means that I add val to the bucket modulo 10. On the next line, I want to see if there are any elements at the bucket modulo 10. So a hash table, which is of type vector, has this method at. So it will return the element at modulo 10. And we know that that is of type node, it's a pointer to node. So on the if branch, I check that the pointer to node is null. If it is null, it means that I have to create a new node. So, and also put it into the bucket modulo 10. And this is what I do here. Now you can see that on this line, I commented out. So I use this to debug this program. And it means that I just want to say write out, it is null. And this is the carriage return character. I wanted to see if for each, whenever I run this program, if I'm in the if branch or if I'm in the else branch. And now if linked list for val is not equal to null, it means that the bucket is not null. So there are elements there. So it means that I want to insert at the beginning of the bucket. So I now use insert at beginning val, which is the element that I want to insert, and hash table at modulo 10, which actually can be, it is actually equal to linked list for val. So I could modify that here. And I'm actually going to do that to make it more interesting. Okay, now I want to see, I wrote one more function, look for element, and then the main function that each C++ program needs in order to be run. So let's look first at the look for element function. It returns a Boolean, and it will look for the element val in the hash table here. So you see that here I didn't put an ampersand like this because I don't modify the hash table for this function. On this line, first I want to see if I have a bucket at val mod 10. So I first, so this is actually, my list is the bucket that exists at val mod 10. If, I'm looking for the element. So I'm going to iterate over the elements in the linked list, which the linked list is my bucket. Yeah, so this is a while loop. So while this condition is true, the while loop is going to execute the code here. So, and then the next iteration of the loop, it checks for the condition. If the condition is not true anymore, it's going to exit the loop. So let's see. I have, so first I have a Boolean variable here, answer, which in the beginning is false, meaning that I didn't find the element. And for this if I found the element, so I look at my list, which is right now is one particular node in the list, and it's actually, so my list is of type pointer to node, and that's why I have an arrow here. If it was node like this, so without a pointer, then here I would have dot, but it's not. So I'm going to just revert that. So if the value of my list is equal to val, the input value, then answer is equal to true, because it means that I found my value, and I'm going to break out of the loop and just return the answer. If not, then I will just continue until I find the end of the linked list, which is when my list is equal to null. And at each step, whether I found the element or not, well, if I found the element, I'm going to break. But if I didn't find the element that I'm looking for, then I have to go to the next node in the linked list. And I do that by assigning to my list next. And now for the main function, which has to return an int, this is how it works for the main in C++. First, I declare the variable numLm, which is of type integer. And now I'm just going to interact with the user. So how many elements does the vector have, and write each element. You can actually, this is pretty standard, this part, and the way that I interact with the user on the console. So you can use it from here. So I write out how many elements does the vector have. I use the standard library, and I take in the number of elements, and then here I declare my table is actually my hash table, which will have 10 elements, of course, because there is one bucket for 0, 1, 2, 3, up to 9, which are the possible remainders when you divide a number by 10. So I just chose to represent my hash table as a vector of linked lists. You can represent it in other ways, but this is how I chose to do it here. So now I am going to ask the user to write the element, and I'm going to read the element here. And for each element, I'm going to call my function add to hash table, and I'm going to put lm into my table. And this is a for loop. So I'm going to put into the hash table however many elements the user wants me to put, like num_lm. And on this line, I ask which is the element I'm looking for. I want to see if a new element, if this element is in the hash table or not. So I'm reading the element, and then I'm going to call the function that I declared here, and that I defined look for element, and I'm going to look for lm in my table. So now I'm going to compile this program, since I made a small change here, and then I'm going to run it. This is here. Okay, so first I have to go to the place where this one is, which is in, so first actually save it, downloads and hash table. Okay, let's see what do we have here. Okay. And I installed, this is Ubuntu that I'm working with, and I installed the GCC compiler. And here I want to say that it should use the C++ 11 version. But this is not Quicksort, I used that before. How is my, this is the name of this? Hash table CPP, okay. And okay, it compiled it. So now I can run the output file, which is hash1.out. How many elements does the vector have? Let's say 3 in the beginning. Write element 2. Now I have to write another element 7, and now 12. So which is the element that I want to look for? So now I wrote 2 went in the bucket 2, 7 went in the bucket 7, 12 went in the bucket 2. So let's see. I want to see if 7 is there. Does it know that 7 is there? Yes. Which is the element in the hash table 1. So the way this works is that the look for element is going to return Boolean, and so for true, the corresponding element, the corresponding int is 1, and for false, the corresponding int is 0. And it looks like cout transformed. I mean, it's not going to write true or false. It's going to write 0 or 1. Okay, let's run it again. So 3 again, and I'm going to, let's see, 23 first element, 13. So both of these go into bucket 3 and 3. Okay, and I'm going to look for 33. It should give me 0. Great. So here, the answer is 0. And let's do another example. How many? Let's do something that is like an edge case. Maybe only one element, but you can think of others. To write element 34. Okay, element to look for, 4. Good. So it didn't find it. That's good because the element is not there. Okay. So this was it for how to create a hash table and how to look for an element in that hash table.